Hey guys, we're going to continue factoring quadratic equations, but this time a is going to be greater than 1, so it's going to change things up a little bit. When a is greater than 1 is when the guess and test method gets very difficult and somewhat time consuming. It was the only method I knew of when I was in high school and college, so it was really great when I learned this bottoms up method as a teacher. And I really just learned it just recently, but it is wonderful. Also, what else was I going to say about it? I don't remember, but maybe when I remember, I'll tell you. So first off, I'm not even going to show you guess and test when a is greater than 1 because it's just a waste of our time. So we're not going to factor that. So let's just go straight to factoring a quadratic when a is greater than 1. So I have this equation right here, and a is 4, b is 16, c is 15. Now, everything, because we did bottoms up yesterday when a was 1, pretty much everything's exactly the same today with the exception of one move. Now, first, we're going to look and see, is there a greatest common factor? And I'm looking at the 4, the 16, and the 15, and I'm going to say, no, there's not. So let's see. We're going to multiply a times the c, which is a 4 times the 15, which is 60. All right, now we're going to factor that 60. So there's probably a whole lot of things to factor out of here. So let's see, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12. I think that's, let's see, wait a minute. 6 times 10. Okay, let's look at all of these and say, do any of these add up to B? B was 16. Oh, look, it's the last one that I wrote, 6 and a 10. All right, now, so I'm going to write the 6 and the 10. And we're going to divide both by A. Only this time, A, I'm going to move these over a little bit. 6 and the 10. A is 4. Okay, now, we are going to look at these now as a fraction, and we're going to simplify them. They're both top heavy. We're going to leave them top heavy. We're not going to change them into mixed numbers or anything like that. We're just going to see if we can simplify either one of them. So when I look at the 6 and 4, I'm like, okay, wait a minute. This can be 3 and a 2 if I divide the top and the bottom by 2. And for the other fraction, I can also divide them by 2. And you don't have to divide them by the same thing. You don't have to divide the two fractions by the same number. It can be different fractions. You do have to divide the numerator, and the denominator by the same number. Okay, so now I have 2 new fractions. So this is what happens. I'm going to do bottoms up. So the 2, let me make my parentheses. The 2 is going to come up to the top, but remember the denominator represents the x's, so it's 2x plus 3. The 2 comes up on the second fraction. It represents the number of x's, and there's the 5. Bam! Now I could do my little box method and multiply both of these binomials, and I would end up with the same exact quadratic equation. And that's pretty much it. I mean, we can just do this a few more times, but it's the same thing. Okay, I'm going to check. There's no GCF. Check, check. A is 4, B is 7, C is a -2. A times C is 4 times a -2, which is a -8. I'm going to factor -8. I'll just do it right here. Let's see. There's a negative there, so I have to notice that, but I'm not going to write it in yet, okay? So I know 8 times 1, 2 times 4. I think that's it. Okay. So I want to see, do any of these add up to 7? Well, a positive 7, yes. If I put a negative right here, if I put a negative right here, then this will add up to a positive 7. So I'm going to put the 8 here and the negative 1. I'm going to put the whatever A is. A is 4, so I'm going to put that down below. Okay. Negative 1 over 4, I can't do anything more with. But this one, I can make it be 4 over 2. Wish I'd spread those out a little bit more, but oh well. Okay. Factor, I'm going to make my little parentheses here, and 4 over 2, bottoms up. That's 2x's plus 4. For the negative 1 over 4, bottoms up. That's 4x, and don't miss it, but this is a minus 1. Bam. Oh, now let's look at this next one. It looks a little bit different because the 10 is on the wrong side. We need to have all of these on the same side. So I'm going to subtract 10 from both sides. 6x squared minus 11x minus 10. Remember yesterday in our notes we wrote it has to be written in standard form. So now it's in standard form. Okay, so A is 6, B is a negative 11, C is a negative 10. There is no greatest common factor, no GCF. All right, so let's see. A times C is 6 times negative 10, which is a negative 60. All right, now I'm going to just tell you right now, I'm looking at this and going, oh, I already know what's going to add up. Do I know? No, I don't know. Oh my gosh, I almost guessed, because the first thing that came to mind was, what did come to mind? I don't know what came to mind. Oh, 5 and a 6. 5 and a 6 equals 11, but it's a negative, so that's not going to work. I can't do a negative 5 times 6 or a 5 or a negative 6 times 5 because neither one of those would add up to negative 11. So I have to keep looking. I have to keep trying. So let's see what I got here. I know I have a 10 and a 6. That's not going to work. I have, what else do I have? 12 and a 5. That's not going to work. I have a 4 and, 4 and a 15. Okay, that's going to work if I put a negative in front of what? The 4 or the 15? The 15. If I put a negative right here, 4 plus negative 15 is negative 11. That's what I'm trying to get to, the B. So I'm going to do my 4 and my negative 15. I'm going to divide it by my A, which is 6 and 6. I can simplify both of these. So let's see, 3 negative 5 over 2. All right, so I have this fraction and this fraction that I'm going to do bottoms up with. So 3x plus 2. Don't forget those x's. And then 2x minus 5. Bam. There we go. What else do we have down here? Okay. When A is negative, we need to factor out the negative. Okay, so I'm going to pull the negative out. Negative, negative, negative. Because A has to be a positive number. So we have, now I have 2x squared plus 15x plus 7. I don't have a GCF here, so there's no GCF. No GCF. All right, so then what we got? We have A equals 2, B equals 15, C equals 7. A times C is 2 times 7, which is 14. And so I already can see if I do 14 and 1, there's my 15. So I'm going to put my 14 and my, I'm running out of room, and my 1, and I'm going to put a 2 below and a 2 below. So this one can be simplified to 7 over 1. So I'm going to use this fraction, and I'm going to use this fraction. I'm going to do bottoms up. So bottoms up, I've got x plus 7 and 2x plus 1. And it doesn't matter which is in front of the other. You could do 2x plus 1 first. It doesn't really matter. Okay, now then the last part I have to remember, I factored something out. I factored out a negative 1. Whoops. So I'm going to go ahead and I'm going to put the negative 1 right here. So this is my answer. There's 3 factors. 3 factors. Let's go to the next one. I need to move this 16 over. Negative 3x squared plus 16x minus 16. Now I need to factor out the negative. So I have 3x squared minus 16x plus 16. All right, there's no GCF, so I'm going to go ahead and do A. Let me write it over here. A is 3, B is a negative 16, C is 16. A times C is 3 times 16, which is 48. All right, and I need to think of factors of 48. And let's see, I'm going to go ahead and do 4 times 12, and watch this. 4 and 12 equals 16, which is what I want. But I have a negative 16. So I'm going to put a negative in front of both of them, and now they add up to negative 16. That's one of those sneaky ones. All right, so bottoms up, I have a negative 4 and a negative 12, and I'm going to put a 3. I'm going to put A under both. This one can be simplified. So I'm going to use this fraction and this fraction, bottoms up. 3x minus 4, 1, whoops, let me just call it x minus 4. Bam, I'm done. We're done. Good luck. Ask questions if you need to, and I'll see you next time. Bye-bye.